So my project is FE10's Gen Op Ensemble Transfer Learning with Hyperparameter Tuning using Genetic Algorithm Optimization for Polycystic Ovary Syndrome Detection from ultrasound sonography images. So in this model, the new model that I have proposed, this model I'm applying on PCOS USG images and classifying them. It is a binary classification, and this is a new model, completely new model, along with a new fuzzy inference system that I have introduced for image quality enhancement. As in medical images, there is a high chance of a lot of noise in the image. Hence, we are training the model in such a way so that it detects all the noise as well without any issues. The two models, transfer learning models that we're ensembling is the EfficientNet V7 and the DenseNet 201. And we have done a comprehensive comparative analysis to prove our statements and coming up with the best model, best data set, and best fuzzy inference system. We have taken our model through rigorous training and diverse image variations through augmentation, and then through qualitative quantitative analysis, metrics, performance evaluation, accuracy, precision, recall, F1 score, AUC, ROC curves, and then some visualization techniques like class activation maps and k-fold cross-validation with detailed ablation study. So we know polycystic ovary is a huge issue in today's world, especially for women, and the existing architectures or models are not yet that developed. Hence, we propose this algorithm. These are the various issues that happens due to polycystic ovary. So these are the main contributions, and I will also show the code. So these are all the codes that I have run. There are even more codes, but then like inside the files. So the main contributions of the paper are extensive comprehensive comparative analysis between different machine learning models, deep learning models, transfer learning models, and the proposed ensemble transfer learning models to come up with the most accurate, efficient model. Then hyperparameter tuning is being done extensively for better performance of the model, and using genetic algorithm. So using genetic algorithm, we're optimizing the hyperparameters, and then the fuzzy inference system for image quality enhancement is giving a way better result than the usual classification. Finally, various training, testing techniques and qualitative quantitative metrics. Hence, we achieve an efficient detection of PCOS from USG images. A comprehensive detailed literature review has been done here of 40 papers, which has been published in the years 2022 and 2023 mainly, and one or two maybe from 2021. The methodology and the ablation study. So initially the dataset is being taken, raw dataset from Kaggle, and it has two classes, PCOS, non-PCOS, and it has number of images 2284 for PCOS and 1562 for non-PCOS. And then we do the data augmentation. So this data set we upsample it first to 4000 images for each class, and in that we give all kinds of data augmentation factors like rotation, width shift, height shift, zoom, horizontal flip, vertical flip, and the parameter values. We augment and then we also downsample the dataset with the same data augmentation parameters. So we have three datasets. Dataset 1 is the normal one, dataset 2, D2 is the upsampled one, and D3 the downsampled one. Here the accuracy versus number of images is being shown. Hence the optimal one we are getting is at 4000 images. And then we have data augmentation, and as I've already mentioned, these are some scans that you can see from the dataset. This is the algorithm that shows how the dataset is being processed. After that, hyperparameter tuning using genetic algorithm. So in this, I have done all the mathematical calculations and how everything is being considered. So these are the hyperparameters that are selected. The dense units, number of dense units, dropout rate, learning rate, batch size, epochs, optimizer, kernel size, kernel initializer, kernel regularizer, learning rate scheduler, rotation range, zoom range, batch normalization, early stopping. And these are the values that I'm considering for tuning. Now, using genetic algorithms, a genetic algorithm has its own stages: initialization, fitness evaluation, selection, crossover, mutation, replacement. So here the mathematical calculations are being shown for each step that goes for hyperparameter tuning using genetic algorithm. Finally, the comparative analysis for correct model selection. So here the models are taken along with the hyperparameter tuning and genetic algorithm optimization on D1, D2 and D3. So these are the machine learning algorithms and their accuracies. These are the deep learning algorithms and their accuracies. And these are transfer learning ones, and these are ensemble transfer learning. Finally, the best one is given by EfficientNet V7 with DenseNet 201. And when we compare the three data sets also using this one, we find that the upsampling is the best one. This is the overall comparative analysis model. Then we have how we have done the weights and the bias activation function, epochs and the loss function, how we have come up with all these values and everything, what changes we have done. Everything is given here. So we do he initialization and using pre-trained weights from ImageNet, ReLU activation function, and binary cross entropy loss. So everything is being explained here, how changes we are making to make it more optimized. Then the ensemble transfer learning, how the transfer learning model is being prepared, ensembled. So how the feature is extracted from each model that is ensembled. Then how the what is the stacking criteria and how it is derived is shown through mathematical conclusions as well. And finally, alterations that are being done in the existing architecture to build the ensemble model. So these are all explained how we are adding extra layers and why we are adding extra layers, learning rate, kernel size, everything is being explained here. This is the overall diagram for ensemble model. Then train test divide is 70-30, and finally noise is being added. So the optimal noise will be 5% as noise level increases and accuracy decreases. Hence these are the noisy images, training and testing noisy images. Fuzzy inference system, we have three rules as mentioned here. So when the enhancement is When the picture quality is low, then enhancement has to be high, and so on. So we do and we consider the PSNR, peak signal to noise ratio. So here all the comparison is done using different membership functions, what the PSNR is coming at which noise level. Finally 5% noise, and the membership function is being selected. Finally, all the datasets are being compared with genetic algorithm optimization, with grid search, random search, and without any optimization. And we conclude that genetic algorithm is giving way better accuracy than rest. Then the mathematical modeling is being done here. Then analyzing the performance, quantitative metrics like accuracy, precision, recall, F1 score are taken, and some qualitative figures are also taken. Cross-validation, we do the cross-validation. This is the result. 10K we have taken, as K value is better at 10. Finally, the results. So these are all the graphs that have come from different comparative analysis between the models. Overall comparison between the models, the highest given by efficient net B7 with dense net 201 for the different data sets. And finally, the upsample dataset is being chosen. These are the comparisons for the membership function and the values of the uh, PSNR at different noise level. This is the final membership function that is being taken, Gaussian and triangular. The enhanced image is being shown here. So the top 3 models are compared with and without optimization. Finally, the final model accuracy, F1 score, everything has been calculated and given. The confusion matrix and the ROC AUC curve has been given, and the detection has been shown. And the hyperparameters of it, so we ran 50 generations, hence every generation hyperparameters have been shown, how they have been trained, and finally the best one is being chosen, which is this table gives the best one. And finally the convergence graph, learning rate versus training accuracy, loss accuracy versus epoch, and performance of each k-fold cross validation we see. And finally class activation map we see in the image segmentation. Finally comparison with existing literature review based models. So these are the citations, and these are the models and the data size and data set and the accuracies with my proposed model. And finally the conclusion and discussions containing the advantages of this model and the future scope, and this is the references. And these are the model code that has been done. More codes are there, and so here I come to the end of the model presentation. Thank you. I am Ananya Ghosh, 20MIC0063.